Yeah. So let's go ahead with the today's session. We are dealing with the aldehydes, ketones, and carboxylic acids, right? So in the last class, if you remember, we had our last class on Tuesday, right? Last Tuesday. After that, we did not have class. So in the last class, we have discussed about the chemical properties of aldehydes and ketones, right? So we are in the first chemical property, which is nucleophilic addition reaction. Okay. So we have studied the mechanism of how to add the nucleophile to C double bond O in the aldehydes and ketone functional group part and etc. etc. And after that, we have came across with some of the compounds. Like we have seen the addition of hydrogen cyanide, addition of sodium hydrogen sulfide, and addition of Grignard reagents. Okay. So we have completed these three addition into the aldehydes and ketones. All right. So we have some more compounds to add to the C double bond of aldehyde and ketone. So we will discuss that in today's session. Okay. So these are the three subdivisions under this nucleophilic addition reaction. We have two more subdivisions. Before going on to that, I have got one test for you, question, okay, which is a recall test. So try to answer for this question. Once we complete this, we will move on to that. What is the name of the product in the addition of HCN to carbonyl group? Can anyone give the answer for this? So we have studied this, right? So we are taking a ketone or aldehyde, and this is actually the reaction of HCN, addition of HCN to the system. So cyanide is getting added. Then on hydrolysis, we are getting one compound which has CN group and OH group. So I told you one name for the compound which has CN group and OH group. Can anyone give me the name of the final compound? The general name of the final compound? Do you guys remember? Bhagat, Christina Priyadarshini, Deva, Harish, JNV East Godavari 1, JNV Kokrajar, Madhukar Reddy, RJK, Sivamani Vedant. What is the name of the final compound? I hope you guys are taking the notes of the class which we are taking, right? So try to find out the name of the compound. Try to find out the name of the final compound. The compound which has CN and OH group is called as. What is the answer? Very good, Harish. Exactly. It is called as cyanohydrin. Yes. This is called as cyanohydrin. Okay. Very good, Bhagat. All right. So today we will go for the fourth compound, okay, fourth nucleophile, which is the alcohol. So addition of alcohols to the carbonyl group, okay. So I am taking an aldehyde, okay, of formula RCHO, and I am going to add the alcohol. So the general formula for alcohol is ROH, okay. So I am going to add this, and in presence of HCl, okay. So in presence of HCl, what does this HCl do? You know, this dry hydrogen chloride gas protonates the oxygen. Okay. Oxygen of the carbonyl group. So protonates means the H plus of the HCl will go and get attached with the oxygen of the aldehyde. Okay. So now what happens? The alcohol will come and form the bond with the carbon of the carbonyl group. Okay. So we get a compound like this. So carbon is attached with OR and oxygen is attached with H. All right. So since we have one OR group, this compound is called as hemiacetal. Okay. And then if you add one more mole of alcohol with dry HCl, you will get another compound. Okay, in that compound, you will have two OR group. So it is called as acetal. Okay, so a single carbon is attached with two OR group. So it is called as acetal. So if two OR groups are attached to the same carbon, then it is called as gem dialkoxy compound. So the OR group is called as alkoxy. Okay. So we have two alkoxy, and if two groups are attached to the same carbon, it is gem. Gem means geminal. Okay. Vicinal geminal. You might be aware of these two terms, right? We have already studied these terms in the haloalkanes and haloarenes lesson. So if two groups are attached to the same carbon, it is called as geminal dialkoxy compound. Okay. So you may be thinking like, ma'am, how do I get the two OR groups attached to this particular system? So here you have to remove the H2O. Okay. You have to remove H2O like this, and you have to attach the OR of alcohol group to the carbon. Okay. Yeah, yeah. Sure, ma'am, sure. Fine. So similarly, so this is an aldehyde, right? This is an aldehyde. So similarly, ketones also react with alcohols to give ketals. So from aldehydes, we are getting acetal, right? In the same way, if you take some ketone, it will give you ketal. Okay. So acetals and ketals are hydrolyzed with aqueous mineral acid to yield the corresponding aldehydes and ketones respectively. So the third point says that if you treat this acetal or ketal with H3O plus. Okay, this is aqueous mineral acid. With H3O plus, it will give back the aldehyde or ketone again. Okay, so this process is reversible. So if you treat the acetal with H3O plus, it will give you aldehyde or ketone. If you treat aldehyde or ketone with HCl and alcohol, you will get acetal or ketone. Ketal. Okay, so it is the other way around. So this is what is about addition of alcohol. Okay, so coming to the fifth reaction. So we have one more reaction. Okay, it is the reaction with ammonia and its derivatives. Do you guys have any doubt in the addition of alcohols? Is it clear? Is it clear? Is it clear to all of you? Shall we go for the last addition? Yes. Okay. The fifth is the reaction with ammonia and its derivatives. So what is the formula for ammonia? Ammonia means NH3. Okay, and its derivatives. Ammonia is NH3 and its derivatives means you have to replace this hydrogen with some other group. Okay, if I am replacing this hydrogen with one R group, what I will get? I will get RNH2, right? So this is called as the derivative of ammonia. Okay, so the R groups can be anything. We are going to discuss about this only. Okay, R group can be anything. Now, let me take an aldehyde. So, let me take an aldehyde and I am going to add the derivative of ammonia. Okay, here Ez, this Ez denotes the R which I have explained. Okay, so Ez is some other group. We will discuss about that Ez later. So, if I treat aldehyde with the derivative of ammonia, the H2O will be removed. Okay, the oxygen from aldehyde part and the H2 from the derivative of ammonia part will go out as H2O and we will get a compound like this. Okay, we just have to connect this carbon and nitrogen. That's all. So we have double bond here already. So carbon, double bond, nitrogen we are getting with the removal of H2O. Okay, so now let's go ahead with the divisions of this Z. So what will be the product if the Z is R? If the Z is R, then the compound is called as amine. Okay, RNH2 is called as amine. So if you remove the water molecule, what will you get? If you remove this water molecule, you'll get C double bond N R. So C double bond N R containing compounds. R means you all know, right? What is R? R is an alkyl group, right? Methyl, ethyl. So those are called as R groups. So if you have C double bond N alkyl group, then it is called as substituted imine. It is called as substituted imine, which is otherwise called as Schiff's base. Okay, very important. Substituted imine or Schiff's base. Okay, it is called as imine only if it is attached with the alkyl group. Okay. So now let's go for the second compound. Second is the reaction with hydroxylamine. So what is hydroxylamine? If this Z group is OH, if this Z is OH, then it is called as hydroxylamine. Then the process is same. You have to remove this water. On removal, we will get C double bond N OH. So if you have C double bond N OH component in your compound, then it is called as oxime. It is called as oxime. Okay, if it is alkyl group, it is substituted imine. If you have OH, it is called as oxime. Okay, do you have any doubt from the slide? Shall I go for the third compound? Shall I go for the third compound? So we have studied the addition of amine to aldehyde and addition of hydroxylamine to reaction of hydroxylamine with aldehyde. Shall I go for the third compound? Students? Yes? Okay. So now coming to the third compound. Third is a reaction with hydrazine. So what is hydrazine? If the Z group is NH2, it is hydrazine. Okay. So NH2 bond NH2 is called as hydrazine. Then if you remove the water particle from this, you will get C double bond N NH2. Okay. This is called as hydrazone. Okay. From hydrazine, we will get hydrazone. Then the fourth is reaction with phenyl hydrazine. So what is phenyl hydrazine? NH2, NH2 is hydrazine. If you replace one of this hydrogen in hydrazine by phenyl group, this is the phenyl group, right? So it is called as phenyl hydrazine. So on removal of H2O, we will get phenyl hydrazone. Phenyl hydrazone. Okay. Everything remains same. Only thing is there is one substitution. Okay. Phenyl group is substituted with the hydrogen. That's all. Okay. Next. Coming to the fifth compound. Fifth is reaction with 2,4-dinitrophenylhydrazine. So what is 2,4-dinitro? So this group is called as phenylhydrazine. Okay, and this is carbon number 1, 2, 3, 4, 5, and 6, right? So if there are two nitro groups attached at second position and fourth position, then it is called as 2,4-phenylhydrazine. Okay, Harish want me to show the previous slide? Okay, wait. Harish, done with it? Okay, okay, fine. So what I was saying? Yeah, 2,4-dinitrophenylhydrazine is the name of this compound. So if I add this compound to the aldehyde, what will I get? H2O will come out and we will get 2,4-dinitrophenylhydrazone. Okay, hydrazine will be converted to hydrazone. That's all. Okay, this compound has one color and the color is red precipitate. This compound will settle down in the container as orange red precipitate. Okay, so because of this, this reaction is used for the test for the carbonyl group. Test for the carbonyl group and the name of the test is 2,4-DNP test. 2,4-dinitrophenyl test. Okay, phenylhydrazine test. So why? Why this reaction is used for the test for carbonyl group? If there is no carbonyl group in your compound, this is carbonyl group, right? If there is no C double bond O group in your compound, then you will not get orange red precipitate. We will not get the orange red precipitate, right? Only if there is the presence of we will get orange red. So if orange red color is not observed in the container, then we can come to the conclusion that the compound which we took in the container that does not contain C double bond O group in it. Okay. So if there is no C double bond O, there is no color formation. If there is C double bond O, then we will get orange red precipitate. Okay. So this is how they will differentiate, and they are using this as a test for the presence of carbonyl group. Is it clear to all of you? Any doubt? So why the 2,4-DNP test is used? It is used to test the presence of carbonyl group. Okay, this is one very important question. You should know. Shall we go for the next? Students, shall we go for the next? Okay. Okay, all right. So the sixth one is reaction with semi-carbazide. So we have an aldehyde, and I'm going to add semi-carbazide. You see the compound NH2, NH, C double bond O, NH2. This is semi-carbazide. So what we have to do? Remove H2O. You will get C double bond N, then the remaining component will be there. This is called a semi-carbazone. This is called as carbazone. Okay. So with this, the nucleophilic addition reactions are getting over. Okay. So the first chemical reaction is nucleophilic substitution. So there were how many nucleophilic substitutions are there? Students, there are 5, right? So there are 5 nucleophilic substitution. 3 we have already discussed. Okay, first is the addition of HCN. Second is the addition of sodium hydrogen sulfide. Third is the addition of Grignard reagent, RMGX. And today we have studied the fourth reaction, right? Addition of alcohol, ROH, and at last, addition of ammonia and its derivatives. Okay. So these are the 5 nucleophilic, sorry, this is not nucleophilic substitution, this is nucleophilic addition. Sorry. Nucleophilic addition. Okay, so these are the 5 nucleophilic addition reactions we have studied. And under this ammonia and its derivatives only, there were 6. Okay, there were 6 addition. Got it? Everything is okay? Shall I go for the second chemical reaction? Do you guys have any doubt in the nucleophilic addition reactions of aldehydes and ketones? You have any doubt, students? Shall we go for the next? Are you all ready? Okay, very good. So the second reaction is reduction. Reduction of aldehydes and ketones. Okay, in the nucleophilic addition only we have studied many reactions. So don't get scared, okay? So in reduction and in the upcoming reactions, there will be very few reactions only. You don't have to get scared. So let us go for the reduction of aldehydes and ketones. So if we reduce an aldehyde or ketone, we will get alcohol. So that is what we are learning from the last lesson itself, right? So if I'm taking an aldehyde or ketone, if I try to reduce it, I will get an alcohol. And if I oxidize the alcohol, I will get aldehyde. So the process is the opposite, right? So reduction means I will get alcohol. So the first reaction is reduction to alcohols. So reduction means we have to use some reducing agents, right? So the reducing agents are hydrogen in presence of platinum and nickel, which is called as catalytic reduction. Why it is called as catalytic reduction? Because platinum and nickel are the catalyst. Okay, what is a catalyst? The one which is used to speed up the reaction, or the one which alters the rate of the chemical reaction. Okay, they are called as catalyst. So platinum and nickel are the catalyst here. Okay. And the second reducing agent is sodium borohydride. And the third one is lithium aluminium hydride. So these are the 3 reducing agents which we use here. Okay, for the reduction of aldehyde and ketone. So let me go for the reaction. So take an aldehyde and add H2 in presence of platinum or nickel. So this aldehyde will produce alcohol, right? So what alcohol? CH2OH. CH2OH. Since this compound is an aldehyde, it will form primary alcohol, right? Aldehydes form primary. You see the formula? We have R CH2OH. So it forms primary alcohol. And ketones will form secondary alcohol. Ketones will form secondary alcohol. Okay? So this is the reaction, general reaction. So now let's go for some examples under this topic. Okay? So let's go for some example. So I have taken one compound whose name is pent 3-enal. So 1, 2, 3, 4, 5. Okay, pent. 5 carbons are there, so pent. Between third carbon and fourth carbon, we have a double bond, so it is 3. And at the first position, we have aldehyde, right? So it is pent 3-enal. So now I am going to treat this compound with two different reagents. First, I am going to treat this with hydrogen in presence of platinum. Secondly, I am going to treat this with lithium aluminum hydride. Okay. So what will be the product? What do you think about the product that we get from these two reactions? Do you think that we get the same product for both or different products? Can you guess? Can you guess the product? Will it be same for both or it will be different? It will be different. Okay, very good. Why it is different? Why it is different and what? Can you try to find out the name of the product that we get from these two reactions? Rohit Mugilan, you said it is different. No, answer is correct. But why and how? I have given the explanation for this question in the previous lesson. Okay, when I was pent 3-enol. Pent 3-enol. Pent 3-enol is for which reaction? For the first one or for the second one? For the first, pent 3-enol. Then pentanol is for the second reaction. Lithium aluminum hydride will give pentanol. Let's see. Let's see the product. Okay. Listen. From hydrogen presence of platinum only, we get pent-1-ol. Okay, which is pentanol. And from the second reagent, you see, lithium aluminum hydride and sodium borohydride cannot reduce multiple bonds. This is what I have taught in the feature, right? Feature of the reducing agents in the previous lesson. So, lithium aluminum hydride will not reduce the double bond, but it will reduce only the aldehyde group. So, here we will get pent-3-enol. Here we, now we are saying it is vice versa. Yeah, your answer is correct, but it is vice versa. But initially you gave me the wrong answer only, no? You said pent-3-enol is for the first reaction. You little bit got confused. Okay, no problem. Now we are clear, right? Now we are clear, right? Okay, that's great. So students, listen. So all of you can able to understand, right? What I'm trying to say. So hydrogen and platinum, what they will do, they can reduce both the double bond as well as the aldehyde. So aldehyde, as usual, if they are getting reduced, they will form alcohol. And the double bond, if you are reducing, it will form, hydrogen will get added like this and they will form CH3, CH2, CH2. So we get pent-1-ol. So 1, 2, 3, 4, 5. Okay. So it is pent-1-ol or pentanol. And coming to lithium aluminum hydride, since they cannot reduce the multiple bond means the double bond and the triple bond. Okay. So the double bond will not change, will not get affected. Only the aldehyde will be converted to alcohol. Okay, only the aldehyde part has been converted to alcohol. But here both alcohol and alkene was affected. Okay. So the name of this compound is 1, 2, 3, 4, 5 pent 3-en-1-ol. So is it clear to all of you? Is it clear to all of you? Do you guys have any doubt? Okay, what about others? What about others except Harish and Rohit Mohil? What about others? Bhagat, Madhukar Reddy? Okay, great. So this is the first reaction. Okay, first reaction under the reduction. So first we have reduced the aldehydes and ketones to alcohols. So now let's go for the second. Reduction to hydrocarbons. So aldehydes and ketones can be reduced to hydrocarbon. Hydrocarbons means hydrogen and carbon containing compounds, okay, which are basically alkanes. Okay, so here we will mainly focus on alkanes. Alkanes, alkenes, and alkynes. All the three are hydrocarbons, right? So here the aldehyde will be converted to alkanes. So in this conversion of aldehyde to hydrocarbon, we have two reactions, and both the reactions are very important, and both of them are named reaction. Okay, so the first reaction is called as Clemmensen reduction. Both of them are easy. Okay, it is not a big reaction, very small only. First one is Clemmensen reduction. So Clemmensen is the name of the scientist, and they used one reagent to reduce the aldehyde to alkane, and that reagent is zinc amalgam in presence of HCl. Okay, zinc amalgam. Zinc amalgam means zinc mercury. So zinc mercury with HCl. So here if you see, the C double bond O will be converted to CH2. Okay. C double bond O is converted to CH2. So what you need to do? You just need to memorize this reagent. Zinc amalgam and the mercury. So which is actually called as Clemmensen reagent. Okay, suppose if I have CH3 C double bond OH. Okay, so in presence of this Clemmensen reagent, what I will get? The C double bond O will be converted to CH2. So I will have CH3, CH2, and also I have one H. So it is CH3, CH2H, or it is CH3, CH3. Okay, is it clear? So this is the Clemmensen reduction. Now the second reaction is called as Wolff-Kishner reduction. So Wolff-Kishner reduction will also give you hydrocarbons, but the reagent will be different. Okay, the reagents are NH2NH2 with KOH. NH2NH2 with KOH. Hydrogen with KOH. Okay, so they will also produce the same compound, alkane. They will also produce the same compound, alkane. Okay, products are same. Okay, but the reagents are different. You should memorize the reagents. Okay, NH2, KOH is the reagent for Wolff-Kishner, and zinc amalgam with HCl is the reagent for Clemmensen. Okay, so these are the two reactions in which we get the hydrocarbons from the aldehydes and ketones. Is it clear to all of you? Shall we go for the third chemical reaction? Any doubt so far for anyone? Yes or no? Okay. So the third type of reaction is called as oxidation. Just the opposite of reduction, right? Oxidation of aldehydes and ketones. So aldehydes are easily oxidized to carboxylic acids on treatment with oxidizing agents like HNO3, KMNO4 in basic medium, and K2Cr2O7 in acidic medium. So if you are oxidizing an aldehyde, you will get carboxylic acid. Okay, these are the oxidizing agents. So take an aldehyde, use one of the oxidizing agent given, you will end up with carboxylic acid. Okay, RCOOH is called as carboxylic acid. Okay, so aldehydes will give carboxylic acid. So what about ketones? Ketones are also oxidized. Ketones are generally oxidized under vigorous condition. Vigorous means strong oxidizing agent should be used and the temperature should be very, very high. Okay, at elevated temperature and with the use of strong oxidizing agent, ketones can be oxidized. Okay, so what you can do, I will give you one example. So this is an example for one ketone. Okay, ketone is treated with KMNO4 and OH minus. Okay, KMNO4 and OH minus. So now here what will happen? Two compounds will form. So two carboxylic acid will form. Okay. So it is because the oxidation is very difficult for ketone. I have already told you, right? The reactivity will be more for aldehydes compared to ketone. For nucleophilic addition, we have studied. No, the same thing is for ketones also. I mean, for oxidation also. Okay. Not major. There will not be any major difference between aldehyde and ketone. Little bit. Little bit. So ketones need some high temperature to get oxidized. Yeah. So here we are getting two different products, but how do we know that this product will form from this particular thing? We do not know, right? So the red color C double bond O is getting formed with one product, but it is absent in the other product. So we have 1, 2, 3, and 4 carbon. So in the first compound, we have 2 carbon. In the second compound, we have 2 carbon. Okay. So how do we get this product? So there is one rule which is called as Popov rule. So according to this rule, okay, Popov rule according to which the carbonyl group of the unsymmetrical ketone remains with the smaller alkyl group preferentially. So in this ketone, we have two alkyl group. One is ethyl, this is ethyl, and this is called as methyl. So methyl has one carbon and ethyl has two carbon. So the C double bond O group of the ketone will remain with the smaller alkyl group. Okay, so we have methyl, right? So the C double bond O of this ketone is remaining, staying with the smaller alkyl group, and then the other things are getting oxidized. Okay, so here we get OH, and in the ethyl we have two carbon, right? So those are these two carbons. Okay, is it clear for all of you? So since we have an even number of carbon, you may get confused. I will try to explain this with one more example. This bond will be broken down. If I have CH2, CH2, CH3 like this. So what will happen? So this is propyl and this is methyl. So again, methyl has only one carbon. So the C double bond O will stay with methyl and will give this product. And the other product will be C double bond O OH, C double bond O OH, CH2 and CH3. So is it clear now? Is it clear now? The C double bond O will remain with the smaller alkyl group and the more number of carbon containing alkyl group will form another carboxylic acid. 3 carbon containing carboxylic acid. So this rule is called as Popov rule. Okay. Clear? So you should memorize the oxidizing agents list. HNO3, potassium permanganate and potassium dichromate. Okay. So we have seen a list of reducing agents, right? Hydrogen with platinum, nickel, lithium, aluminum hydride, and sodium borohydride. So in the same way, you have to memorize this for oxidizing agents. All right, students, shall I go for the next one? Shall I go for the next slide? Do you have any doubt? So aldehyde and ketone on oxidation will give carboxylic acid. So that is the main point which you have to take from this slide. Let me go for the next. Yes. Okay. So the next is about the next point about the oxidation is the mild oxidizing agents. So mild oxidizing agents like Tollens reagent and filling solution can oxidize only aldehydes. Hence, it is used as a test for aldehydes. So we are going to study these two reactions now. Okay, the very first is the Tollens test. Okay, Tollens test. It is also called a silver mirror test. Okay, these two tests are used for the test for aldehydes. All right. So in tolerance test, we use one reagent and that reagent is called as ammoniacal solution of silver nitrate. Ammoniacal solution of silver nitrate. So let me show you the tolerance reagent. And this is a reaction. So this is aldehyde. Okay, this is an aldehyde. And it is treated with tolerance reagent. This is ammoniacal silver nitrate solution. Okay, ammoniacal silver nitrate solution. If an aldehyde is treated with this ammoniacal solution of silver nitrate, it will produce a carboxylate ion. RCOOH is called as carboxylic acid. Okay. So if I get RCOO minus and H plus, this is called as carboxylate ion. Okay. Means it has undergone oxidation. It has undergone oxidation. So aldehyde is getting oxidized to carboxylate ion with the removal of Ag, NH3 and water. So what is Ag? Ag is silver. So silver mirror is observed in the container in which we are doing the reaction. So let me show you. So all of you can able to see the picture, right? So we have a test tube and we are doing the reaction in this test tube. And if the compound is an aldehyde, we will get a silver mirror at the walls of the test tube. Can you all able to see the silver mirror formation in the test tube? Can you guys able to see the silver mirror formation in the test tube? Yes? Yes or no? Okay, listen. So both aliphatic and aromatic aldehydes give tolerance test. Both aliphatic aldehyde and aromatic aldehyde will give tolerance test. Okay. So aliphatic aldehyde means CH3, CH2, CHO, some alkyl group attached with this. And aromatic means the phenyl ring containing compound, benzene containing compound, benzaldehyde and its derivatives. So both aliphatic and aromatic aldehydes gives tolerance test. Okay. So now the second test is Felling's test. So here we have to take a Felling solution. So there are two components. One is Felling solution A and that is copper sulfate solution and the other one is Felling solution B, which is the solution of sodium potassium tartarate, which is also called as Rogel salt. Okay, sodium potassium tartarate is also called as Rogel salt. So we have Felling solution A and we have Felling solution B. And if you mix A and B together, you will get the final Felling solution. Okay, it will give you the Felling solution. So it is a deep blue colored complex. So this is that Felling solution. Okay, mixed A and B mixed together, you will get like this. So if I am treating this deep blue colored Felling solution with some aldehyde, again the aldehyde will get oxidized and we will get Cu2O and H2O as the byproduct. So how do we know that the aldehyde has got oxidized? Okay, so using an indication, and the indication here is the presence of red-brown color of the compound. Okay, so the blue colored complex, if it is turning into brown, red-brown colored precipitate, then you can say that the compound that I have taken here with the Felling solution is an aldehyde. Okay, it is an aldehyde. If there is no formation of brown color in your test tube, then the compound that you have taken along with this Felling solution is not an aldehyde. It is some other compound. Okay, if you are seeing the brown color, then you can say that it is an aldehyde. But here there is one exception. Only aliphatic aldehydes respond to this test, not aromatic aldehydes. Aromatic aldehydes do not respond to this test. Okay, aromatic aldehydes do not respond to this test. Only aliphatic, like ethanol, propanol, butanol, only those kinds of aldehydes. Aromatic aldehydes do not respond. This is an important point. You will get statement type of question or the reaction based question from tolerance test and Felling's test. Clear? Okay. So the color is very important. Okay. Try to memorize the color. Try to memorize the color. Yes. So I hope everything is clear so far. So oxidation is also getting over here. So let me summarize the three chemical reactions that we have studied so far. Okay, the very first is nucleophilic addition, and we have discussed about this in detail. And today I have discussed about the reduction. The very first one is catalytic reduction. And also we have used Clemmensen reduction, zinc amalgam and HCl. And Wolff-Kishner reduction is having hydrogen and KOH. Okay. So in both the cases, we are getting an hydrocarbon. And the third reaction is oxidation. So aldehydes are oxidized to carboxylic acids. Ketones are also oxidized to carboxylic acids. And there were two tests. One is tolerance test, in which we use ammoniacal silver nitrate solution. And if there is a presence of silver mirror, then it is an aldehyde. Both aliphatic and aromatic will respond to this. But when you go for the second one, only the aliphatic will respond to this test and it will give red-brown precipitate. Okay. So deep blue colored copper solution is called as filling solution. Okay. So this is what we have studied so far. So now we have some more, right? We have some chemical properties is not yet over. We have some more reactions to discuss. So the fourth reaction of aldehyde and ketone is reactions due to acidity of alpha hydrogen. We are going to study some reactions. Okay, there are some subtopics and all those reactions concept is the reaction due to acidity of alpha hydrogen. They all deal with the alpha hydrogen based thing. Okay, so now you should know what is alpha hydrogen, right? And why the alpha hydrogens are more acidic. You should know the reason for this question. So let me take an aldehyde to explain this. So RC double bond O CH3. So this is the example I have taken. C double bond O is called as carbonyl group. Okay, this is called as carbonyl group. The carbon which is adjacent to this carbonyl group is called as alpha carbon. This carbon is called as alpha carbon. And the hydrogens which are attached to this alpha carbon are called as alpha hydrogen. Okay, this is one of the alpha hydrogen and the other two are also called as alpha hydrogen. Okay, can you all able to understand which is alpha carbon? Don't get confused. The carbon which is adjacent to C double bond O is called as alpha carbon. Okay. So now we are going to discuss about the acidity of these hydrogens. Okay, acidity of these alpha hydrogens. They are basically acidic. All the alpha hydrogens are basically acidic in nature because they are adjacent to C double bond O group. We all know that C double bond O group is an electron withdrawing group. So they will withdraw the electrons from the CH3 group here. So they become acidic in nature. They become electron deficient and they are acidic. Electron deficient species are called as acids, right? So they are acidic in nature. But we are discussing about two compounds. One is aldehyde and the other one is ketone. For aldehydes, if you take the pKa value is 17 and for ketone, the pKa value is 20. If the pKa value is greater, then the acidity is lower. If the pKa value is greater, then the acidity is very less. So pKa is inversely proportional to acidity. pKa is inversely proportional to acidity. So ketones have the highest pKa value, so they are less acidic, and aldehydes are more acidic. Okay, aldehydes are more acidic than ketones. Is it clear? So what are the points? Alpha hydrogens are acidic in nature. When you compare aldehyde and ketone, aldehydes are more acidic compared to ketone. Okay. So in ketone, we have two alkyl groups, right? So since we have two alkyl groups here in ketone, so both will donate the electron. and they will decrease the acidity. Plus I effect means positive inductive effect. They will donate the electrons, and the C double bond O group, that compound is less electron deficient. So it is less acidic in nature. Is it clear? Shall we go for the reactions due to alpha acidity of alpha hydrogen? Shall we go under this? Able to understand why ketones are less acidic than aldehydes? Students? Yes. Thank you, Bhagat. So the first reaction under this is, so we are discussing the fourth chemical reaction, and this is the subdivision of fourth. Okay, fourth reaction. So the first subdivision is iodoform reaction. So what is this? So here we are taking a compound, and I have taken ketone. Okay. It is treated with iodine of NaOH. The ketone is getting converted to sodium carboxylate compound, and the CHI3 is coming out. So CHI3 is called as iodoform, and it is formed as an yellow precipitate. This is the reaction. Okay. So this is used as a test for methyl group. This is used as a test for methyl group in the carbonyl compound. Okay, test for methyl group. So let me expand this. R, C double bond O, CH3. So this is the ketone which we are taking. Okay. So C double bond O is here, and the carbon, this carbon is alpha carbon, and all these hydrogens are alpha hydrogens, and they are acidic. Okay. Now the reaction is happening at the center only. So the CH3 is getting converted to ONA. The CH3 is getting converted to ONA. Okay. So only if you have CH3, you will get ONA, and iodoform will form, and it will give you the yellow precipitate. Okay. Clear. So the compound which has only the methyl group will respond to this. Okay. Some alcohols, apart from this ketone, some alcohols also respond to this test. I will show you which alcohol will respond and which compound will respond. See, CH3, CH2OH, this alcohol will respond, and CH3, CHOH, CH3 alcohol will respond. Because in these two compounds, if you see, we have CH3, CH, OH, and H. This is first alcohol. And the second alcohol is CH3, CHOH, CH3. Right? CH3, CHOH, and CH3. So, to be very simple, I will tell you, I will give you a trick. The compounds which contain CH3, C double bond O group and CH3, CHOH group. CH3, CHOH group. The compounds which contains these two groups will give the positive result for iodoform reaction. Okay, otherwise you will not get the iodoform as an yellow precipitate, and it will not respond to this test. Okay, this is very important reaction. So in these two alcohols, if you see, we have the CH3 CHOH component. So that's why these two alcohols will respond to this test. If you go for ketone, ketone has CH3CO group. So ketones will respond to this test. Okay. Deva, you want to explain once again? Yeah, I will. Listen, the compounds which has CH3C double bond O group and CH3CHOH group will respond to iodoform reaction, iodoform test. Respond in the sense you will get the answer. You will get this iodoform and the other compound. Okay, RCOA compound in your reaction. If you have some other component apart from these two, you will not get the positive test. So let me take you one question. Let me give you one question so that you can understand. Listen. Give simple chemical test to distinguish between the following pair of compounds. And the answer is Iodoform test. Okay, I will give you the answer. Answer is iodoform test. Why? Why using iodoform test we can able to distinguish these two compounds? Pentan 2-one and pentan 3-one are the compounds. Okay, so let me give you the structure. Pent means 5, right? CH3, C double bond O, CH2, CH2, CH3. This is pentan 2-one and pentan 3-one. CH3, CH2, C double bond O, CH2, CH3. This is pentan 3-one because 1, 2, 3, 4, 5. C double bond O is present at the second position and here it is present at the third position. Okay. So this is pentan 2-one and this is pentan 3-one. Now, how using the iodoform reaction you can able to differentiate? Because pentan 2-one has CH3CO component. So it will respond to the iodoform reaction. But pentan 3-one doesn't have CH3CO. Instead of CH3CO, it has CH3CH2CO. Okay, so this will not give the positive result for iodoform reaction. So we will not get any yellow precipitate for pentan 3-one. So we can able to distinguish which is pentan 2-one and pentan 3-one using I2 and NaOH, which are the reagents used in iodoform reaction. Can you able to understand now? Deva, can you able to understand? Is it clear? Deva from JMB Guntur, can you able to understand? Let me show you the reaction also. Okay. Let me show you the reaction, complete reaction. You see. So here the compound is reversed. Okay. Otherwise it is same only. So this is pentan 2-one, 1, 2, 3, 4, 5. So if they are treated with I2 and NaOH, we will get NaOI as the compound. You can write NaOI or I2 with NaOH. Both are same only. Okay. So here the CH3 group is getting converted to ONA and this is CHI3, which is called as iodoform. This is called as iodoform, which is an yellow precipitate. Okay. This is pentan 2-one. It is a methyl ketone. It is a methyl ketone. It has methyl group, so it is a methyl ketone. It responds to this test, but pentan 3-one, which doesn't have methyl ketone, does not respond to this test. Okay, it does not respond to this test. Okay, students able to understand? Can you all able to understand? So we have started with the fourth chemical reaction. And this is the first subcategory under this, which is called as iodoform reaction. Okay. Any doubt from iodoform? Do you guys have any doubt from iodoform? Okay, all right. So I have got one information to share with you guys. So it is for JEE aspirants, okay? So the students who are appearing for the JEE examination, the last date to apply for your JEE exam is 22nd of November, okay, 22nd of this month. And try to apply in the first session, okay? So apply in the first session, the last day to apply is 22nd November. Clear? 22nd November, try to go for first session. Okay. So I hope today's session is very useful for all of you guys. So we will go ahead with the next reaction in the next class. Okay. Till then, take care. Bye-bye. JEE chemistry is easy only. JEE chemistry is almost 80% up to the 80 to 90% is up to the level of NEET only. Okay. JEE chemistry is easy. JEE advanced is little bit difficult, but JEE mains is up to the level of NEET only. Okay, Harish. So I have launched a poll for you guys about physics. You have to ask your physics teacher. In physics, you more numericals are involved, right? More problem solving you have to do, and you have to practice with more number of questions. Okay, it will be little bit difficult. Okay, as I know, it is physics is little bit difficult because more problems are involved. But in chemistry, we have both problem solving as well as some theory based questions. But in case of physics, there will be some formula based questions, but there will be more number of problems. Okay, numericals. So there you have to give more attention, more concentration to get very good marks in physics. So you can do it. If you are doing hard work, you can do it. Crack it for sure. But Harish is trying for NEET, right? Harish is a NEET aspirant, no? Do you have maths? Do you have maths as one of your subject in your school? Then you can try for JEE also if you wish. Okay. So four students have not given me the feedback yet. Harish, Sivamani, and one student from JNB East Godavari 1 and one from JNB Kakinada. So try to give your feedback in the form. Yeah, you can try. You can try, Harish. So students, if you have answered for all the five questions which is given in the feedback form, you can leave the class. Otherwise, answer for all the five.